Hello everyone, my name is Alexander Leonov and today I would like to talk about vulnerabilities, and more precisely about vulnerability databases. I work at Tinkoff. I'm dealing with vulnerability management there. Prior to that, I worked at Positive Technologies for more than 6 years. And I have a blog, avleonov.com, about information security automation. So, please visit and subscribe. Well, what I would like to talk about today, about what problems. In general, everything is pretty bad with vulnerabilities. Vulnerabilities are poorly described in vulnerability databases. Knowledge bases of vulnerability scanners are incomplete. Vulnerability detection methods implemented in the scanners are not good enough. And the current vulnerability management processes also have some problems. Well, that's what we'll talk about. Well, what public vulnerability databases do we have? I tried to classify them. The main classifier, which I came up with, is the following. There are individual vulnerability databases in which one identifier means one vulnerability. They try to cover all existing vulnerabilities. And others are security bulletins. They cover vulnerabilities in a particular product or products. And they're usually based on patches. One patch may cover multiple vulnerabilities. This is my big picture for all the vulnerability databases. Not for all, those that I remember. On one part of the picture are databases of individual vulnerabilities. The most important is National Vulnerability Database. Well, there are also Chinese, Japanese bases that can be derived from NVD and not. On the other side of the picture we have security bulletins, for example Red Hat security advisories. And in the middle we have vulnerability databases for which it is not critical whether they have duplicated vulnerabilities or not. These are the vulnerability databases of aggregators, vulnerability scanners, security content databases. We can say that overall OpenVIS NVTs are the forms of public security content. Well, Russian FSTEC vulnerability database also has individual vulnerabilities and security bulletins. What's the difference between individual vulnerability databases? Vulnerability is actually a bug. It's not easy to understand how critical it is. We can approve more vulnerabilities and we will have some trash in the database. We can approve only critical vulnerabilities and then we most likely will not have the full coverage. Well, here is the difference. Fortunately for us, the main vulnerability database is the National Vulnerability Database by NIST. The primary identifier is CVE. How does this ID appear? The researcher or the vendor reports to MITRE that vulnerability was detected. He says, I have found a vulnerability. They give him a CVE identifier and it will be used for references in all other databases. In NVD, exploit databases and in some media resources, so it will be clear that we are talking about the same vulnerability. How to understand which vulnerability is critical and which is not? You can use the data from the NVD. We'll talk a little more about it later. And if we need some information about exploitability, public exploit malwares that use this vulnerability, we need to use external sources. How the vulnerability in NVD is described. We go to the site and we see the identifier, description, CVSS base score and vector, links, description of the links, type of vulnerability CWE and vulnerable platforms CPE. What problems we have with them? CVSS is a great way to describe vulnerability. But since this is a questionnaire filled in by some person, it is rather subjective. You'll get what you have filled. And in fact, we only have a base score and base vector from NVD. And everything else, temporal and environmental part, we need to calculate ourselves at take somewhere. CWE, Common Weakness Enumeration, is the label, which shows what kind of vulnerability we have. The idea is excellent, but the implementation is rather strange. For a third of CVE vulnerabilities, we don't have this label. And for others, it's not some critical labels that indicate an injection, for example. The most widely used label is buffer overflow. And in practice we see the description says remote code execution, and in CWE we see input validation.
Code execution, remote code execution. А в описании уязвимости заглядываем, ну, там, в CWE заглядываем и видим input validation. То есть чисто заточившись на вот эти вот
CWE
или нет. Не всегда понятно, как ее эксплуатировать.
And it's not clear how to exploit it. It's easier to start parsing the description.
Вот. CPE,
list of vulnerable software. On the one hand, it's fun. You see at once which versions of software are vulnerable. But only if these identifiers are correctly filled. There are some CVEs in which literally all versions of some software marked vulnerable. Of course, this is wrong, and if you automatically process these data, there may be some problems. If you make a chart for software and vendors with most CVEs, does it show something or not?
Хочется спросить вообще, она что-нибудь показывает или нет? Вот, несмотря на то, что этот график...
I have made it and I think it does not show much.
Не особо она что показывает. Вот, это по продуктам, а вот это вот по
This is for products and this one is for vendors. Large number of UCVEs can mean that it is really a bad product.
Дырявый, там постоянно уязвимость находит, а может быть потому, что он просто
Or maybe it is just a popular product. People check it more often because it is important. Or maybe vendor of the product is responsible and it tries to get CVE identifiers for every vulnerability. In fact, the vendor means a lot. Most of the information about vulnerabilities comes directly from the vendor. And the vendor often suffers from this. Last year, there was a funny story about Palo Alto Networks. They had an RCE in some versions of PAN-OS, and they wrote on the website that all the versions of up to 6 are vulnerable. Patches will be released for the versions of PAN-OS more than 6. There is a link to Palo Alto site for CVEID at NVD. Well, since the FSTEC base takes data from NVD, this vulnerability appeared in the FSTEC base as well. And this led to the cancellation of certificates on PAN-OS 4. That is the fourth version, for which a patch will not be released and vulnerability will not be fixed. By formal signs, they said, okay, then we will throw it out from our register of certified software. What I would like to say about this, on the one hand, it's great that they clean registry from the vulnerable products. On the other hand, how would they know about this vulnerability if not from the vendor itself? And where do you push the vendor? Do you want incomplete information and corrupted vulnerability data from him? But in fact, it was a single case, no more certificates were cancelled. And in 2 months, these certificates would have expired in any case. Let's move on to the scanners now. The scanner is a vulnerability database with some detectors that were written by the vulnerability scanner vendor. As a result, we have a product, enter targets, launch a scan, get raw results. Then these raw results are displayed as dashboards, reports and other beautiful things. Using my own scanner, which I am making in my free time, as an example, I will show the methods of vulnerability detection. The most popular way is detection without authorization. We scanned some server, got a list of open ports and running services. And using the list of these software services by version, we find out whether they're vulnerable. We can find suitable CVEs of the same NVD database. The problem is that the versions that we got from the service banners will not always be correct. Nobody can guarantee this. In the case of backported patches, they're likely to be incorrect, and this will lead to false positives. Credentialed scans are better because we can pull out a list of software packages from the host and get vulnerabilities for them from security bulletins. What are the disadvantages? We need an account that will be used to execute some commands on the host. So, we must trust the software which will pull out the data. Because it can somehow damage the systems which we analyze. When we use agents, we also need to know that it will not do anything wrong. And here I brag that my scanner used query language inspired by Splunk. The coolest way to detect vulnerability is, of course, with an attempt to exploit it. But the problem is that such checks are more difficult to write. Not all vulnerabilities can be checked in such way. Sometimes these checks can be dangerous and can somehow damage the work of the target hosts. There is a point of view that all scanners detect vulnerabilities identically and that the knowledge bases are the same. Just think about all existing software products and all vulnerabilities in them. Each vendor must develop some enormous number of checks. Let's look at Nessus and OpenVA's knowledge bases, crossing them by CVE. Thousands of CVE vulnerabilities can be detected only by OpenVAS or only by Nessus. It's true for this year vulnerabilities as well. Exploitability flag is also an excellent feature of vulnerability scanners. We can see that some vulnerability has a property. There is a public exploit. But not always this is an adequate information. For Nessus plugins with no exploit, I was able to find exploits on vulners.com by CVE. So do not trust it and check it out manually as well. Well, finally, let's talk a bit about the processes. Nearly all vulnerability management vendors promote the concept of continuous monitoring. Constantly scan, constantly learn what vulnerabilities appear on the perimeter and inside the network, quickly fix them. The real processes are different. For example, Qualys published a report about MS17010 detections among the clients. This vulnerability led to CryptoCloaker epidemics. То, из-за чего работали криптолокеры в прошлом году, WannaCry, там Петя и вот... WannaCry, Petya and others like them. В общем, идея такая, что... The number of detections increased significantly only when news about mass infections began to spread. Когда начались сообщения в СМИ о том, что вот все, короче, массовые заражения, да? Только в этом случае народ
Only in this case people began to scan something, and as we see by the second hunt, they started to patch actively even later.
Пока гром не грянет, мужик не
Unless thunder strikes, a man won't cross himself, but sometimes it's even good. Another fairly recent case, Meltdown Spectre at the beginning of the year.
Meltdown Spectre в начале года, громкая уязвимость.
An important vulnerability in the processes. On the second day, all vulnerability management vendors say patch this vulnerability immediately.
Вот вышли патчи, срочно ставьте эти патчи. Вот, ну,
normal behavior for a vulnerability management vendor. But in a few days we learned that these Windows patches on Windows 7 cause a blue screen. Cool.
Круто. Еще буквально через несколько
In just a few days we learned that Ubuntu Linux kernel with this patches does not boot. Great.
Офигеть. То есть, еще буквально через
In
несколько
just a
дней
few
мы
days
узнаем,
Intel
что
says, do not use our patches, they have bugs.
Intel говорит,
Excellent.
не используйте наши патчи, они бажные. Отлично. Но и это еще не все. Еще там через какое-то время узнаем, что патчи
Windows 7, which Microsoft released, created even more critical visibility than the Spectre and Meltdown.
Еще более критичную уязвимость, чем, собственно, Spectre и Meltdown. То есть, возможно,
it was probably better to do nothing at all than to believe the M vendors and patch immediately, at least in the case of Windows 7.
Патчится оперативно. Ну, во всяком случае, в случае Windows 7. Ну и там совсем недавняя новость,
And quite recent news is that for some old processors, patches will not be released because Intel does not want to.
Патчи, потому что Intel не хочет просто. Ну и в конце, что хотелось бы сказать? Ну да, вот.
Well, in the end, I would like to say, yes, there are some problems with everything.
Плохо. Что, собственно, делать-то, да?
What actually should we do? Any organization will need a vulnerability to scanner anyway.
Но учитывая, что один сканер уязвимости,
but considering that they pretty often detect different things, it's better to use several scanners.
То, что они детектят, оно не всегда пересекается, да? Лучше использовать несколько сканеров уязвимости, несмотря на то, что они достаточно дорогие.
Despite the fact that they are quite expensive.
И вторая тема,
and the second topic, you found some vulnerabilities. In order to correctly prioritize them, information about exploits and malware will be needed.
Для того, чтобы грамотно их приоритизировать, нужно информация по сплойтам и малварям. И, скорее всего, она будет внешней.
And most likely this data will be external, so you'll need some external utilities to process it.
И сопоставлять, скорее всего, с помощью внешних каких-то утилит, как серебряный пуль.
There is no silver bullet, you'll have to write your own code.
Вот чем я, собственно, в компании занимаюсь.
What I'm actually doing in the company and what I advise you to do.
Не полагаться на серебряные пули.
Do not rely on silver bullets, understand your needs and implement the logic that is right for your organization.
Реализовывать какую-то вот логику, которая подходит именно для вашей организации. Вот. Все.
That's all. Thanks a lot. I will be glad to answer the questions if we have some time.
Да, пожалуйста.
The first question is about your scanner. Is it possible to try it?
Сканер пилится.
The scanner is in development. You can give it a try a bit later.
Чуть позже, да.
Does your scanner use any other vulnerability database or only NVD?
Ваш сканер, он как бы не только, я так понимаю, НВД использует, да?
В данный момент НВД. Вот.
Currently it uses only NVD. In fact, the mapping other vulnerability databases to NVD is a separate process. I haven't seen comparison of Chinese bases with NVD.
То есть, я не знаю какого-то исследования, кто бы реально там вот сопоставлял китайские базы и базу НВД. Ну, потому что там на иероглифе все написано непонятно.
Well, probably because of hieroglyphs and so on. Yes, we are working on this. Thank you.
Спасибо. Да, пожалуйста.
Привет, спасибо большое за доклад.
Hello, thank you very much
У меня
for
такой
the
вопрос.
My question, you have
Очень
told
много
a lot
сказал о
about the
том,
problem of
что
vulnerability
есть проблема
description in bases.
с фиксированием
All
этих
this is very
уязвимостей
bad,
в
all
базах.
this is very ugly.
Все это очень плохо, все это очень некрасиво, и я, в принципе, согласен. Только вот такой вопрос. Собственно говоря, из доклада я понял, что была предложена некая концепция решения этих проблем локально, да, то есть в какой-то вот компашке, да, а может быть есть какие-то предложения улучшить категоризацию этого всего в общем? Спасибо.
Thank you. This should be handled by those who work at NIST.
Те, кто, собственно, внести, собственно, почему внести там есть не все, и почему там есть...
Why there are vulnerabilities not presented in NIST NVD and why there are such errors.
Наверное, можно NIST просто
As a member of community, we can indicate to NIST we have found some problem here, we have found a problem there, and somehow push them in the right direction. About creating another vulnerability database in which there would be absolutely everything. Well, you can try, but I especially do not believe in it. We need to work with the source.
Спасибо большое.
Thank you very much.
Спасибо большое.